Rest and motion are fundamental concepts in physics that describe the state of an object or system in terms of its position relative to a reference point and its change in position over time. Rest refers to a state in which an object or system remains stationary or at a constant position relative to a reference point. In other words, there is no change in its position over time. Motion, on the other hand, refers to a change in position of an object or system with respect to a reference point over time. It can be described in terms of displacement, velocity, and acceleration. Motion can occur in different forms, such as linear motion, straight line motion, circular motion, rotational motion, and oscillatory motion. Motion can be categorized into various types based on different criteria. Here are some common types of motion. 1. Translational motion. Translational motion refers to the movement of an object from one point to another in a straight line, without any rotation. Examples include the motion of a car along a straight road or a person walking in a straight line. 2. Rotational motion. Rotational motion involves the movement of an object around an axis or a fixed point. It occurs when an object spins or rotates about its center or a fixed point. Examples include the spinning of a wheel or the rotation of a planet around its axis. 3. Vibrational motion. Vibrational motion refers to the back and forth or oscillatory motion of an object around a fixed position. It involves the repetitive motion of an object about its equilibrium position. Examples include the motion of a pendulum or the vibrations of a guitar string. 4. Oscillatory motion. Oscillatory motion is a type of vibrational motion where an object moves repeatedly between two extreme positions or states. It involves periodic motion around a central point. Examples include the swinging of a pendulum or the motion of a spring. 5. Circular motion. Circular motion occurs when an object moves along a circular path or trajectory. The object continuously changes its direction, but the distance from a fixed point remains constant. Examples include the motion of a satellite orbiting the Earth or a race car moving around a racetrack. 6. Periodic motion. Periodic motion is any motion that repeats itself after a fixed time interval. It can be in the form of oscillations, vibrations, or any other repetitive pattern. Examples include the motion of a swinging pendulum or the rotation of the Earth around the Sun. 7. Linear motion. Linear motion refers to the motion of an object along a straight line. The object moves in a single dimension, either forward or backward. Examples include a ball rolling down a slope or a car moving along a straight road. 8. Curvilinear motion. Curvilinear motion is the motion of an object along a curved path. The object follows a trajectory that is not a straight line. Examples include a car moving along a curved road or a projectile's path. These are just a few examples of the different types of motion. In reality, many objects can exhibit combinations of these motions or more complex forms of motion based on their characteristics and interactions with their surroundings. Periodic motion refers to a type of motion that repeats itself after a fixed time interval. In other words, it follows a regular and predictable pattern. Examples of periodic motion include the swinging of a pendulum, the oscillation of a spring, the rotation of a planet around the Sun, and the vibration of a guitar string. These motions can be described using mathematical functions such as sine or cosine waves. On the other hand, non-periodic motion refers to a type of motion that does not repeat itself in a regular or predictable manner. It lacks a specific pattern and may exhibit random or irregular behavior. Examples of non-periodic motion include the motion of a car in city traffic, the flight path of a butterfly, the movement of a falling leaf, and the turbulence in fluid flow. Non-periodic motion is generally more complex to describe mathematically and may require statistical or stochastic methods to analyze. It's important to note that some motions may exhibit a combination of periodic and non-periodic behavior. For instance, the motion of a swinging pendulum gradually loses amplitude due to the effects of air resistance and friction, becoming less regular over time. Uniform motion and non-uniform motion are two concepts used to describe the movement of objects. Uniform motion. Uniform motion refers to the movement of an object in which it covers equal distances in equal intervals of time. In other words, the object's speed remains constant throughout its motion. For example, if a car travels at a constant speed of 60 km per hour, for 1 hour, it will cover a distance of 60 km. The motion of the car in this case is uniform. Non-uniform motion. Non-uniform motion refers to the movement of an object in which it covers unequal distances in equal intervals of time. In other words, the object's speed changes during its motion. For example, if a car starts from rest and gradually accelerates, its speed increases over time. In this case, the car's motion is non-uniform since it covers different distances in equal time intervals. Similarly, if the car slows down or decelerates, its speed decreases over time, leading to non-uniform motion. In non-uniform motion, the object's speed can change due to various factors such as acceleration, deceleration, or changes in direction. It is important to note that non-uniform motion does not necessarily mean the speed is continuously increasing or decreasing. It simply means that the speed is changing at different points in time. To summarize, uniform motion involves constant speed in equal distances covered in equal intervals of time, while non-uniform motion involves changing speeds and unequal distances covered in equal intervals of time.